Welcome to, I guess, another class, okay, for advanced functions. So still an introduction and primarily review of the grade 11 concepts. Now, you've run into quite a few parent functions in grade 11 where we can now, do all kinds of transformations and sketches of those parent functions throughout to utilize them in possibly various applications in the future. So I'm going to go through actually quite a few of these parent functions, right? So there is about 9 of them here, which summarize more or less all the ones that you kind of have run into at some point. And on the right hand side, you'll see that I'll try to concentrate on, thinking back of how does a sketch of these look like, what the domain and ranges are, kind of where they're increasing. So, as kind of the input x increases, what happens to the functions? Are they increasing, decreasing? Are there any asymptotes maybe, or possibly discontinuities in them? Intercepts, kind of zeros, to refresh ourselves on that. And then what happens on the kind of end behaviors that we have as your inputs approach infinity, or your inputs approach negative infinity. So what happens to these functions? Do they blow up, or do they maybe go to a particular asymptote? And then, are these functions odd or even? Okay, which is a topic that was also discussed. I can put up a link up above there to that odd and even junk that you studied. All right, so let's take a look at these. Okay, so we'll try to look at them one by one. Okay, so for the first one, okay, so for this particular function, so that's as simple as it possibly gets, right? So this is, really your y is equal to x, which is just a straight line with a slope of 1. Okay, so sketching it is very, very simple, okay, in this particular case. So I'm going to do a little bit of a sketch, and then I'll try to do the sketches of the other ones as well. So let me try to do that here. So if we have, so this is your x and your y, okay, and I'll try to do the sketches, right? So for this function right here, so obviously everyone should remember, a nice straight line that we have, okay, for that. Now, the domain on this is very simple because it includes all x, right? There is nothing really of a worry here. So our domain is all real numbers. Our range also is all real numbers because this function just goes off from negative infinity all the way up to positive infinity. Okay. Now, is it increasing or decreasing? Well, clearly, if you're going in this direction, it's going to be increasing, and if you're going in this direction, it's going to be decreasing, right? So that's what you see to the values. There are no asymptotes in here, so it's not like the function approaches anything, right? It's actually a straight line all the way through. There are no discontinuities. It's always continuous. Remember, discontinuities means that there is some kind of a break in your function, right? Where there's a jump from one point to another, so you see a little bit of a break. The intercepts, there's really just intercept at the origin, right, that you have. And as x approaches infinity, so as you keep going in this direction, y, okay, or the function itself approaches infinity as well. It blows up. And on the negative side, so if you're going in this direction, okay, your y also is going to be blowing up. Now, this is actually an odd function. So remember that if we would substitute, so if we're going to substitute, so in this case f1, so negative x. If we substitute negative x, what we're going to get is negative x back, which really equals to negative of f1 of x, right? So that is the definition of an odd function. So that one is odd, okay, throughout. So that's the first one. All right, let me remove this out of the way. Now, what about the second one? So the second one is our, famous parabola that we have. So x squared, so you may remember. So this one kind of looks like this, right? I'm going to try to shift it up. Okay, it's definitely very symmetrical, so I'll try to do that. Okay, I mean, do it as best as I possibly can, so it kind of goes off like this. Okay, so that's x squared. Now the domain, again, so it's going to include all your inputs, so all the so x is going to be all values of the real number line, okay, because it includes everything. The range, however, notice that the range is going to be stuck, so it's stuck, right? It will include okay, all the real numbers, but equal to 0 or above. So that's what you will have for the range. And of course, it's a set, so you can write it out as a set if you like. Okay, so that's your range. Now, is it increasing or decreasing? So now here it actually will depend. So it looks like, so if we're going in kind of this direction down, it looks like it's decreasing from the negative side to 0. And then from 0, okay, here it looks like it's increasing again. So that's what you have there. And then it's in reverse if you're going in the opposite direction. Are there any asymptotes? No, there's actually no asymptotes. It doesn't approach anything. It just starts to blow up on us, okay, all the way throughout. There are no discontinuities, so there's no breaks in this function at all. The intercepts, again, it kind of touches off at 0, and then nowhere else, okay, so even the y, okay, so it only just crosses through that 0 there point. So that's what we have there. Now, what happens as it approaches infinity? Okay, so as it keeps going in this direction, well, it keeps blowing up. So it just blows up to infinity. And then what happens if it's approaching negative infinity in this direction? And again, it actually blows up on us. Okay, so it goes to positive infinity there. Okay, now, is it an odd or even function? This is an even function, because if we substitute negative x into it, we actually get the function back. And that should not surprise you at all, because if you substitute this and you square it, it's going to give you your function back. So it is an even function. So that's the second one that we have. So let's keep going, right? So that's 2 out of the way. So that's these 2 gone. What about this one? So x cubed. So how did this one look like? We can certainly sketch it, okay, throughout. So you may remember that this kind of looks like this. It, goes like that, and then it blows up in this direction. All right, so that's your x cubed. Okay, so that's what we have in there. And now the domain, well, the domain is actually all real numbers again, right? So it's everything. The range is going to be also all real numbers. So unlike x squared, where it's just everything above 0, including 0, here we actually have it all the way throughout. Now, is it increasing or decreasing? This function actually keeps increasing on us, right? So, if we start from the negative side, it's going to keep increasing here, and it also continues to increase here, right? So this function actually is increasing for all x. Now, if you go in the negative direction, then it's going to be decreasing all the way down. Are there any asymptotes? No, there are no asymptotes in here. Okay, it just straight continues to blow up on us, okay, both in the positive direction and in the negative direction as you're going through. All right, now discontinuities, nope, there are no breaks in this parent function, okay, at all. It's just very continuous, okay, so throughout. Any intercepts? Still, the only intercept is at the origin. All right, so that's where it crosses your x and your y. Okay, and then what happens as you approach positive and negative infinity? It blows up. So positive infinity blows up into positive. Negative infinity, if you keep going further and further, it just starts to go to negative infinity. And this is an actual odd function. And again, so the way to test it is you substitute negative x, you simplify, so this is just going to be this, which gives us our function back, and it's negative, which makes it odd. All right, so that's another one that we have and we can put in our back pocket to understand. Now, to be honest with you, you can just keep going, right? You can say x to the 4th, x to the 5, x to the 6th, 7th, and so on. So those were known as power functions, and they actually alternate. So when x is to an even number, you may remember it kind of looks closer and closer to kind of x squared, except it kind of gets compressed down near the origin. And then when it's x to an odd number, it's going to look very similar to x cubed, okay? Except again, it's going to either have some compressions or stretches. So that's what you will see. So that's why understanding x squared and x cubed is kind of useful, because it carries out through all your power functions with the exponents being bigger than just 3. Now, what about the next one? So this one right here, so 1 over x. So this is actually a kind of a funky function, that we have. And here we finally see some kind of a discontinuity at 0 because we have 1 over x. So we know x will not be defined at 0. It will be defined everywhere else. So our domain is going to be all real values except x is equal to 0. So we have a discontinuity there, right? So there's a break. And moreover, we're going to have an asymptote, okay, at x is equal to 0, okay, like this. And we also will have an asymptote, okay, kind of at the flat horizontal. Because if you try to sketch this out, so you may recall, as you get, if you come from the kind of x positive side and you keep going here and you try to approach 0, okay, so what's going to happen is this function kind of looks like this, where, as x gets bigger and bigger, because it's in the denominator, you notice that, so as x tends to infinity, okay, then our function tends towards 0 because it's 1 over a very big number. And then as it gets closer to 0, okay, so as we know, 1 over a very small number, it starts to blow up on us. So we have asymptotes in these directions, so both on the vertical side at 0 and also on the horizontal side. All right, it's not defined at 0 at all. And then as we switch over, then this function flips. So now, because the values are negative, so it's going to start looking like this. Okay, now it doesn't have exactly this curve, right? So it just kind of goes like that. There we go. All right, so we have a discontinuity at 0. And again, these asymptotes carry out. So we get closer and closer to 0 from the negative side. And then we get closer and closer to infinity as we approach 0. So that's 1 over x. It's still a function though, all right? So the range actually is the same as the domain. It's going to be all real values except 0. So it won't include that. And, as you're going through, so notice if you're going from the negative side, so if you go in this direction, so here it's going to be decreasing. And then also as you carry on in here, it's also decreasing. So it looks like it's going to be decreasing, okay, depending on where you start, all right? And if you go in the opposite case, then it was going to be increasing in this direction and increasing in that direction. So there is that discontinuity that we talked about. I mentioned the asymptotes at 0, okay? So our functions approach that. And then we see what happens as we get as x gets towards infinity, function tends towards 0, and as we get towards negative infinity, our function also tends towards 0. Now, is this odd or an even function? So this one is not one that we kind of mentioned before. However, if you substitute, so if you substitute negative x in here, you're just going to get negative 1 over x. So notice it's an odd function. Okay, so that's what you would have in there. All right, but you have that discontinuity at 0. Now, the next one, I'm not actually going to say a lot, okay, about this next one, which is the absolute value function, because we have actually taken it up in full in advanced. Okay, we've taken kind of all the items, and you may remember, this looks like a nice kind of a V like this, okay? So it's defined, the domain is for all x, the range is actually at 0 and up. We can see that it is basically made up of 2 lines. So it's decreasing in this direction, and then it's increasing in this direction, right? There's no discontinuities, kind of no asymptotes because it's not approaching anything. The only intercept is at 0, okay? And it is an even function this time around, because if you substitute negative x inside it, okay, you're just going to get absolute value of x because it always takes the positive side. So this one, if you want a lot more, I'll put up a link because we had made a video just on the absolute value itself. Now, what about, kind of our square root? This is one of the odd functions because if you remember, for square roots or any roots, and in particular roots that are even, odd ones, it's a different story, but for even ones, so just the square root itself, it has this weird shape. Where it's only defined, okay, and it goes like this. So it's only defined from 0 on the positive side, because on the negative side, we can't really plug in a negative number and take the square root of it. So, we could if you started to learn about complex numbers, but you probably have not at some point, but maybe you have. But for real numbers, because we're just interested on the real number line, okay, so we would say that the domain here is basically from 0 and increasing. So it's on the positive side. Now the range is also from 0 up. All right, so that's what you would have in here, okay, for that square root function. Okay, now is it increasing? Yes, so it just keeps increasing in that direction. Technically there's no discontinuities on x is equal or greater than 0 because there's no break. You know, you might say, oh, isn't there a discontinuity because you're on the left hand side, but the function is not defined, okay, on the negative numbers. Okay, so there's no discontinuity, at least it's not considered one. It would have to continue on and be defined on that particular domain. All right, now intercepts, not really any. I mean, we're touching at 0 there, but other than that, it doesn't intercept anything. Okay, and then as x approaches positive infinity, okay, the function also starts to blow up on us. All right, now is it odd or even? It's neither. Okay, so we can't really say that in here because we can't plug in the negative x because it would not be defined for us. Okay, so it's not an odd or an even function. Okay, it's neither of the two. All right, now please do remember, because sometimes it's convenient where we kind of like to have negative square root of x, and this one, you know, on the flip side, it basically kind of looks like this, right? It's the mirror image across there, and that's kind of how it looks like, and we define this with a negative in front. But whenever you see a square root, you always assume that it's positive there. All right, so let me remove this. So that's another parent function, okay, that we have out of the way. So here are two. Okay, so both this one and this one. So these are exponential parent functions. Now this b, notice I didn't put a number in here, but this b just means base. So here for the first one, the base is between 0 and 1. And for that case, you may remember that this kind of looks like this. It goes through 1 and then it kind of slowly approaches 0. All right. So slowly, I mean exponentially approaches 0, so can't really say slowly, but it approaches it that way. So there is an intercept at 1, okay, for that. So this is for b between 0 and 1, so that's for that function. The domain is basically any x, right? So for any value or real value of x, so that's fine. The range is actually, okay, so this is greater than 0. So it's any real number that's greater than 0, okay, within here. So it blows up on that side, okay, and then it gets close to 0 but never gets there. No matter what we have for x, it just gets kind of, you know, smaller and smaller, right? And now, is it increasing or decreasing? Well, as you can see, it's just decreasing all the way down, right? The asymptote, we do have one. We have the asymptote at 0 because it approaches that 0 right there. There's no discontinuity here, right? It's all continuous. There's no breaks. And as I mentioned, the intercept happens at 1, okay? And that's the intercept on the y. There are no zeros. It doesn't cross through the x at all, okay? Now, as x approaches infinity, so as it gets bigger and bigger, our function tends towards 0. As x approaches negative infinity, okay, our function blows up. So it goes sky high. Now, is this odd or even? Neither. Because if you substitute negative x in there, you're going to get b to the negative x, okay? And it's not going to be an odd or an even function at all. All right? Now, the opposite side, so if you take b, okay, so if your base here is greater than 1, you can assume it's 2. Most of the time, that's what, you know, that's what happens. So here you can, let's say it's like saying 1/2 to the x, okay, if it's between 0 and 1, you know, you can plot that, and then 2 to the x. I can actually drop the brackets here, I don't need it. And then you can compare these two, which is most often done when you're just learning about exponential functions. All right, so in those cases, when b is greater than 1, this actually looks much different. So it's very small, and then it goes through 1, and then it blows up, right? It exponentially blows up. So it's kind of like, if you remember from grade 11, you know, your exponential growth and exponential decay. So it's growing in this case, so it's increasing. Okay, our domain is all x. Our range, again, is just y above 0. Okay, we don't have, in terms of discontinuities, we don't have any, but we do have an asymptote again, and that's when x approaches negative infinity, that asymptote is going to be 0 because it approaches that. Okay, and it's not an odd and it's not an even function, so it's neither of those. All right, so that's pretty neat, and this kind of leaves us, I guess, with the last parent. We could have picked any trigonometric function, so it could have been cos. You typically either pick sine or cos, and you may or may not remember those ones are just a shift from each other. So sine of x, and here it says in degrees, but I also have covered radians. This will depend on your teachers. If you know radians, especially if you're going to go into any engineering side or math, it's good to know, okay, the degrees in radians. So radians was nothing special, right? I guess I can put a link up there back on, introducing you to radians again if you wanted to review it. So here I'll just stick to degrees because it's a little bit easier. So remember that sine of x is really just a ratio, right? It was related towards triangles, and then we're kind of going around this unit circle, back and forth, and sine was the y value, okay, that you would take on within your circle. So you would notice that you have this periodic function, okay, that kind of starts to look like that. So I'm going to just draw it in here, okay, and it kind of looked like this, right? And it just kept repeating. So and this happens for both, and this just keeps going. So it has infinite number of zeros, so infinite number of crossings through x. On the y side, it only has the crossing through the origin, okay, on that. The domain, okay, for this, it's basically any degree that you like, because it's a wheel, it's a circle, right? So if it goes over 360 degrees, let's say it starts over to 361, it just repeats itself over and over and over. So the domain is actually all real numbers on the degree side, or on the radian side, it doesn't matter. The range, okay, for this sine of x, the range is actually constrained between -1 and 1. So the amplitude of this is 1, okay, for that function. So you may kind of recall that. Now, is it increasing or decreasing? Well, in this case, there's all kinds of stuff happening. Because let's say between 0 and 90 degrees, so for the first, okay, little kind of up to here, so it's clearly increasing here, and then it's decreasing all the way down here, and then it's increasing. So you have to be careful how you define your increases and decreases, but of course you will understand. And then that's going in this direction. If you're going in the opposite direction, it's in reverse. There are no asymptotes here. You might think that the asymptote is 1 or -1 because that's as far as it goes. But remember that asymptote means that, as your domain, okay, within your domain, as you keep going in one particular direction, you're getting closer and closer and closer to that asymptote. Here, we never really get closer and closer. We just constantly alternate back and forth, back and forth, back and forth. All right, so there are no asymptotes. There are no discontinuities because there's no breaks in here. So the intercept zeros I mentioned, so those, the intercepts, there are, infinitely many of them, right? It's at 0, okay, then it's at 180 degrees, okay, and then any kind of repetition of it, okay, so that you have. So then it's 360, and so on and so on. Okay, so there's many zeros there. You can kind of write them like this, okay, and I'll put an n multiplied by n, where n is equal to 0, 1, 2, and so on. So every 180 degrees, okay, starting from 0, you'll have those crossings. And then you can also do that both in the positive and negative direction. So maybe I can do that. All right. As x approaches infinity, well, it just continues to alternate. So we're not going to be approaching anything. As x approaches negative infinity, again, this sine function just alternates, so nothing happens. Is it odd or even? So we've actually talked about that in the video on the odd or even. It actually turns out that it is odd, right? And that's if you substitute negative x in there, So you get sine of negative x, which actually is going to give you this back. Okay, so it's odd. Now to finalize these, okay, I know that this is a long review of these parent functions, but I think it's worthy. You know, you could have fast forward maybe some portions or not, but if you reviewed all of these and you're like, oh, great, I kind of remember some of them from grade 11, then awesome. All right, so I'm going to just plot these because I sketched all of them, but we can actually plot it, and I'm going to bring back decimals in here, okay, and we'll plot as many as we can. So obviously, you know, so this is going to be a little odd, but we'll plot them one by one here for completeness, and then that's going to be it. So our first one was just x itself. Okay, so I'm going to go in here. Okay, so we have that. Okay, and let's see if I can remember all of them. Maybe I'll do this so you can see it better. So that's x, right? Then we talked about x squared, right? So that's our parabola that we had. So nothing special. X to the 3. That's why it's so beautiful to have decimals, you know, to get some kind of a visual, right? So that's x cubed. So you notice that that's exactly what we had. And now it's getting a little cluttered. So you know what, maybe I'll just remove and just keep the last one on. 1 over x, okay, so there it is, you know, so you have your approaching it, and then, you know, there's that discontinuity at 0. I mean, I can, let me maybe close this down, and I'll try. Yeah, so this is, you know, when you zoom in, it looks a little better. All right, so that's that. The next one that we had was the absolute value, so this was that, right? That's your v. Okay. What else did we have in there? So we had the square root. Let me pick this square root in here. Pick it off there. Okay, from the bottom. So that's our square root, right? So notice it's only defined. Okay, starting at 0 on. So that's that. Then we had, so those were our exponential functions. So where b is between 0 and 1. You know, I said, you know, we can do, let's say 1 over 2, which, I mean, I guess you could have just wrote a 0.5, let's say, to the x, and notice that's exactly what we had. So it starts to blow up, right, on you, okay, and it goes like that. And then here's the reflection of it. So when x is, when the base is greater than 1, now it goes in the opposite. So that exponential growth, and then this is exponential decay. So that's pretty cool, right, that you can see all of these and graph them. And then finally sine of x, so here it is, and let me kind of go like that. And so within here, okay, so notice if I do negative sine, okay, of x, so that is, you know, that's with respect to that odd. So if you remember, we said it was an odd function. Okay, so in any case, those were all the ones that you had, right? So hopefully that's a good review for you. Glance through it. It's a longer video, but it will bring you back to all of these parent functions. And now hopefully you're also going to try to refresh yourselves on some transformations with respect to these, or at least some of them, just so that you can get your mind back into these transformations. All right. Okay. Thanks for watching. See you in a future video, everybody. Enjoy your advanced functions course. Cheers.